Hello friends, in today's artificial intelligence class we will see the reinforcement learning with very simple example, and this will come under unit 5 learning. What is reinforcement learning? Reinforcement learning is the training of machine learning models. Here we need to train the machines to learn the model, to make a sequence of decisions to reach the goal. Okay, so to reach the goal we need to train the machine by making a sequence of decisions. Hence, the agent learns to achieve a goal in uncertain environment, that is very complex environment. The agent learn to achieve a goal, and in this learning the agent faces game like situation. So on the trial and error basis only it will reach the goal. The solution will be taken only by the trial and error basis. The agent gets either rewards or penalties for the action. If we do the correct action, we will get reward points, and if we do a wrong action, then we will lose the points, that is we will get penalty points. So what is our goal? Our goal is to maximize the total reward points. So how to get the maximized total reward point? By only the trial and error basis. At the first time we cannot get the maximum reward point. So repeatedly we have to do the same process again and again. Finally the machine will learn how to reach the maximum reward points. In many complex domains, reinforcement learning is only feasible way to train the program to perform high levels. So this is what reinforcement learning. What is meant by reinforcement learning? We are going to train the machine. That is, the machine will learn to reach the goal in the sequence of decisions. While doing those decisions, it will do some actions. So if the action is correct action, then it will get reward points. Otherwise it will lose the points, that is penalty points. What is our goal? Our goal is to maximize the total reward points. This is called as reinforcement learning. The reinforcement learn explains how to behave successfully to achieve the goal. To achieve the goal, we need to select the corresponding action, that is the best actions, that while interacting with external environment. Here the external environment are very complicated environment, and this reinforcement learn is otherwise called as learn via experience. At the first step we cannot reach the goal, so repeatedly we learn from the previous experience, then only we can reach the goal. So this is one simple diagram for explaining the reinforcement learning. Here we are having the input raw data, and three different objects are here in this raw data, and our output is we are having three different containers. All the objects are placed correctly in those containers, and this is our reinforcement algorithm. Here this is our first state. First state is given to the agent. The agent is performing on initial state, that is S0, and here it will select the algorithm to choose the best action. That particular best action will be executed on the environment. If the action is correct, then the object will be placed in the correct container, otherwise that will be placed in the wrong container. If it is correct, we will get reward. If it is wrong, then we will get penalty. Point. So repeatedly this process will be executed again and again until all the objects will be placed in the correct container. And next one is types of reinforcement learning. And here we are having two different types of reinforcement learning. First one is passive reinforcement learning and second one is active reinforcement learning. In the passive reinforcement learning, the policy is fixed. Here the agent should learn the utility of states, otherwise the best state and action pass for particular state, that is the current state, which could also involve learning a model of environment. Right? So in this passive reinforcement learning, we need to select the best state action pair on every state. When come to active reinforcement learning, the agent must also learn what to do, and the very big issue in this active reinforcement learning is exploration, because the agent must experience as much as possible on its environment, because the environment is very complicated environment, and in order to learn how to behave in this environment. Okay, so it will select the actions in sequential manner to reach the goal, and at the first time reaching goal is of course impossible. So by experience only it will learn how to reach the goal. And these are the different reinforcement learning. First one is passive and second one is active reinforcement learning. The main terms of reinforcement learning. The main terms are input, output and training. First, the input. Input is nothing but the initial state from which the model will start. Normally the initial state will be S0. And the output. Output is normally G, that is the goal state. In some problems, so many possible outputs may be there, and there are varieties of solution for particular problem. Here we need to select the optimal solution. We need to select optimal solution. And next one is training. Training is based upon the input, and the model will return a state. So if you perform an action, it will return a state and the user will decide to reward or punish. Based on the output of this particular action, the user will get reward or punishment, and the model continues to learn. So based on the reward or punishment, the learning will taken place, and the best solution is decided based on the maximum reward. So these are the main terms of reinforcement learning. And now let us see one very simple example for reinforcement learning, robot and diamond example. Here we are having an agent and a reward and many hurdles in between. That is, we are having an agent is our robot, and reward is the diamond, and many hurdles. Hurdles are fires in between the environment. That is the path of robot and this diamond, and the agent is supposed to find the best possible path to reach the reward. Here we are having robot is our agent, fires, we are having more number of fires in the environment, and diamond, this is the reward of this particular agent. The image shows the robot, diamond and fire. See, here we are having robot, diamond and more number of fires, and the goal of the robot is to get reward, that is to reach the diamond and to avoid the hurdles, that is the fires. And the robot learn by trying all possible path and then choose the path which gives him the reward with least hurdles. That is, the robot can move left side, right side, top and bottom. All the side it can move, but there should in the path there should not be any fire, and each right step that will give reward and each wrong step will give penalty. If it reach the fire square means it will lose some points. The agent will lose some points. So the agent should avoid the fire squares and it will choose only the without hurdle squares to reach the diamond. So the total reward will be calculated when it reaches the final reward, that is the diamond. The Markov decision process of reinforcement learning. Here we are having representation of environment, process, model and assumption. First one is the representation of environment. Here we are having finite set of states. We are having so many states S1, S2 etc. up to S1 and this will be represented as capital S. So we are having S number of states and set of actions. We are having so many actions A1, A2 etc. AN which all represented as capital A. At each what action should be performed at the state S. Okay. So this is called as set of actions and set of states. And next one is process. So what are the process will be taken place? First, at each discrete time step, the agent should observe the state of particular environment, that is the state at time t in the that should belongs to total number of states, and we need to choose the corresponding action at that time, that is small a at time t from the total number of actions. So after that the environment will give the agent an immediate reward at RT, reward at time t, and change the state to ST plus 1. So after getting reward the state will be changed to T plus 1. After executing an action we will get reward, then the state will get changed. And next one is model. So the model initial state is S0. All the execution will start from the initial state only. And the transaction function is T of S comma A comma S dash, that is at this transaction the action will get executed in this initial state and then the state will be changed to S dash. It is probability of moving from state S to S0 when executing the action A. And the reward function R of S, that is the real value reward that the agent receives for entering state S. And next one is assumption. This is Markov property. Transaction S comma A comma S dash, that is the state will get changed to S dash when executing this action on this particular state, and that will get reward of particular state only depend on current state but not on any state visited earlier. This will not affect the previous states but the reward will be given only at the current state. The comparison between supervised learning and reinforcement learning. And these two learning technique, supervised and reinforcement learning, use the mapping between input and output. So every time we need to map input and the output. In supervised learning, feedback is very important concept that will provide the agent is correct set of actions for performing a particular task. But in the reinforcement learning it used the reward points and the punishment, that is the penalty points, as signals for positive and negative behavior. Comparison between unsupervised learning and reinforcement learning. When compared to unsupervised learning, the reinforcement learning is different in terms of goals. The goal in unsupervised learning is to find similarities and differences between the data points. When come to reinforcement learning, the goal is to find suitable action model that would maximize the total cumulative rewards of particular agent. So here we need to maximize the reward points in reinforcement learning. And that's all about the introduction to reinforcement learning. In the next video, we will see the passive reinforcement learning and the active reinforcement learning. And thank you all of you.